Now let's read this blog post called A Successful Git Branching Model by Vincent from 2010. Note of reflection, March 2020. Okay, let's read the note of reflection. This model was conceived in 2010, now more than 10 years ago, and not very long after Git itself came into being. In those 10 years, Git Flow, the branching model laid out in this article, has become hugely popular in many software teams, to the point where people have started treating it like a standard of sorts, but unfortunately, also as a dogma. During those 10 years, Git itself has taken the world by storm, and the most popular type of software that is being developed with Git is shifting more towards web apps, at least in my filter bubble. Web apps are typically continuously delivered, not rolled back, and you don't have to support multiple versions of the software running in the wild. This is not the class of software that I had in mind when I wrote the blog post 10 years ago. If your team is doing continuous delivery of software, I would suggest to adopt a much simpler workflow like GitHub Flow, instead of trying to shoehorn Git Flow into your team. If, however, you are building software that is explicitly versioned, or if you need to support multiple versions of your software in the wild, then Git Flow may still be as good of a fit to your team as it has been to people in the last 10 years. In that case, please read on. To conclude, always remember that panacea. Okay, so why do I have to do this? A solution or remedy for all difficulties or diseases. Great usage of words. Consider your own context. Don't be hating. Blah blah blah. Okay, now I regret reading this. Nothing useful. In this post, I present the development model that I've introduced for some of my projects, both at work and private, about a year ago, and which have turned out to be very successful. I've been meaning to write about it for a while now, but I've never really found the time to do so thoroughly until now. I won't talk about any of the project's details, merely about the branching strategy and release management. Okay, so let's analyze this. So we have time, right here, time. So this is like the past, this is like the present. Then here we have the feature branches, develop, release branches, hot fixes, and master. Okay, so tag is 0.1. So then we go to develop, to the development, we develop something. Okay. Then we go to major feature for next release, right here, and feature for future release. So we're working on that. Okay, we come down here. Incorporate a bug fix in development. We come here. Severe bug fixed for production. Hot fix 0.2. So we do that. We go to 0.2. What happens next? Okay, so we're developing these features here in the development develop branch and feature branches. So start off release branch for 1.0. From this point on, next release means the release after 1.0. Okay, so here only bug fixes. We go again to the develop. We work there. We go to the features. Bug fixes from rel branch may be continuously merged back into develop. Okay, so these are bug fixes. All right. Then we come to 1.0. Okay, well, this is not the best chart, but okay. Why Git? For a thorough discussion On the pros and cons of Git compared to a centralized source code control system, see the web. There are plenty of flame wars going on there. As a developer, I prefer Git above all other tools around today. Git really changed the way developers think of merging and branching. From the classic things I came from, merging and branching has always been considered a bit scary. Beware of merge conflicts. They bite you. And something you only do every once in a while. But with Git, these actions are extremely cheap and simple. And they are considered one of the core parts of your daily workflow, really. For example, in the old world, branching and merging is first discussed in the later chapters for advanced users, while in every Git book, it's already covered in Chapter 3, Basics. As a consequence of its simplicity and repetitive nature, branching and merging are no longer something to be afraid of. Version control tools are supposed to assist in branching and merging more than anything else. Enough about the tools, let's head into the development model. The model that I'm going to present here is essentially no more than a set of procedures that every team member has to follow in order to come to a managed software development process. So decentralized but centralized. The repository setup that we use and that works well with the branching model is that with a central truth repo. Note that this repo is only considered to be central one. We will refer to this GIPO as origin, since this name is familiar to all Git users. So we have origin here, we have sub-team fetches, David and Alice, and here Alice and Bob and David and Claire, and probably between Bob and Claire as well. And we have origin in the center. Each developer pulls and pushes to origin, but besides... Oh wait, isn't there more branches? Each developer pulls and pushes to origin. But besides the centralized push and pull relationships, each developer may also pull changes from other peers to form sub-teams. For example, this might be useful to work together with 2 or more developers on a big new feature before pushing the work in progress to origin prematurely. In the figure above, there are sub-teams of Alice and Bob. Alice and David, and yeah. Technically, this means nothing more than that Alice has defined a Git remote named Bob, pointing to Bob's repository and vice versa. The main branches. At the core, the development model is wait, what's the date of this? 2010. Oh, okay. So yeah, this is actually very old. I made a mistake doing this, but doesn't matter. The central repo holds 2 main branches with an infinite lifetime: master and develop. The master branch at origin should be familiar to every Git user. Parallel to the master branch, another branch exists called develop. We consider origin and master to be the main branch where the source code of head always reflects a production-ready state. We consider origin develop to be the main branch where the source code of head always reflects the state with the latest delivered development changes for the next release. Some would call this the integration branch. This is where any automatic nightly builds are built from. When the source code in the develop branch reaches a stable point and is ready to be released, all of the changes should be merged back into master somehow, and then tagged with a release number. How this is done in detail will be discussed further on. Therefore, each time when changes are merged back into the master, this is a new production release by definition. We tend to be very strict about this so that theoretically we could use a Git hook script to automatically build and roll out software to our production servers every time there was a commit on master. Supporting branches. Next to the main branches, master and develop, our development model uses a variety of supporting branches to aid parallel development between team members, ease tracking of features, prepare for production releases, and to assist in quickly fixing live production problems. Unlike the main branches, these branches always have a limited lifetime, since they will be removed eventually. The different types of branches we may use are feature branches, release branches, hotfix branches. Each of these branches have a specific purpose and are bound to strict rules as to which branches may be their originating branch and which branches must be their merge targets. We will walk through them in a minute. By no means are these branches special from technical perspective. The branch types are categorized by how we use them. They're of course plain old Git branches, feature branches. May branch off from, develop. Must merge back into, develop. Branching names convention, anything except master, develop, release, or hotfix. Feature branches, or sometimes called topic branches, are used to develop new features for the upcoming or distant future release. When starting development of a feature, the target release in which this feature will be incorporated may well be unknown at that point. The essence of a feature branch is that it exists as long as the feature is in development, but will eventually be merged back into develop. To definitely add the new feature to the upcoming release, or discarded in case of a disappointing experiment. Feature branches typically exist in developer repos only, not in origin. Creating a feature branch. When starting work on a new feature, branch off from develop branch. Git checkout B, okay, my feature develop, switch to a new, incorporating a finished feature or develop. Finished features may be merged into develop branch to definitely add them to the upcoming release. Git checkout develop, we're going to the develop. Git merge, okay, I don't know this command. Summary of changes, git branch d my feature, deleted branch, git push origin develop. Okay, the noff flag causes the merge to always create a new commit object, even if the merge could be performed with a fast forward. This avoids losing information about the historical existence of a feature branch and groups together all commits that together added the feature. Compare this. Develop, boom, 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 feature, git merge, plain, or feature branches, then we develop, then we go to the feature, and then we go back to develop. In the latter case, it is impossible to see from the Git repository which of the commit objects together have implemented a feature. We would have to manually read all the log messages, reverting a whole feature group of commits is a true headache in the latter situation, whereas it is easily done in the noff flag if the noff flag was used. Yes, it will create a few more empty commit objects, but the gain is much bigger than the cost. Okay, may branch off from develop, must merge back into develop and master. Branch naming convention, release. Release branches support preparation of a new production release. They allow for last-minute dotting of is and crossing TS. Furthermore, they allow for minor bug fixes and preparing metadata for the release, version number, build dates, and so on. By doing all of this work on the release branch, the develop branch is cleared to receive features for the next big release. The key moment to branch off a new release branch from develop is when develop almost reflects the desired state of the new release. At least all features that are targeted for the release to be built must be merged into develop at this point in time. All features targeted at future releases may not. They must wait until after the release branch is branched off. It is exactly at the start of a release branch that the upcoming release gets assigned a version number, not any earlier. Up until that point, the develop branch reflected changes for the next release, but it is unclear whether that next release will eventually become 0.3 or 1.0 until the release branch is started. That decision is made on the start of the release branch and is carried out by the project's rules on version number bumping. Creating a release branch. Release branches are created from develop branch. For example, say version 1.1.5 is the current production release and we have a big release coming up. The state of develop is ready for the next release, and we have decided that this will become version 1.2. So we branch off and give the release branch a name reflecting a new version number. Git checkout. Okay, I'm not going to go through this one. After creating a new branch and switching to it, we bump the version number. Here, bump version is a fictional shell script that changes some files in the working copy to reflect the new version. This can be manual, blah, blah, blah. Then the bumped version number is committed. This new branch may exist there for a while until the release may be rolled out definitely. During that time, bug fixes may be applied in this branch rather than on the develop branch. Adding large new feature here is strictly prohibited. They must be merged into develop and therefore wait for the next big release. Finishing a release branch. When the state of the release branch is ready to become a real release, some actions need to be carried out. First, the release branch is merged into master. Since every commit on master is a new release by definition, remember? Okay, so I think I understand. Next, that commit on master must be tagged for easy future references to his historical version. Finally, the changes made on the release branch need to be merged back into the develop so that future releases also contain these bug fixes. Okay, I understand. So basically, what I thought before is that when we develop something and we have our release ready, we will just test it on the development branch and merge into master. However, I see now that that is wrong. So we need to create a special branch called release branch. On that branch, we will do final testing, and then that branch will merge into main and into development. I mean, it will overwrite everything. So this is the release branch is the short-lived branch that I guess it's actually development branch with some fixes and checkups. So yeah, the release branch will override all both the master and the development branch. The release is now done and tagged for future references. To keep the changes made in the release branch, we need to merge those back into develop though. In Git, okay. This step may lead to a merge conflict, probably even, since we have changed the version number. If so, fix it and commit. Now we are really done, and the release branch may be removed since we don't need it anymore. So we delete branch. Hotfix branches, okay, may branch off from master, must merge back into develop and master. Branch naming convention, hotfix. Hotfix branches are very much like release branches in that they're also meant to prepare for a new production release, albeit unplanned. They arise from the necessity to act immediately upon an undesired state of a live production version. When a critical bug in a production version must be resolved immediately, a hotfix branch may be branched off from a corresponding tag on the master branch that marks the production version. Alright, so we have master 1.2, we go to develop, we go to hotfixes, and we come back to 1. Whatever. The essence is that work on team members on the develop branch can continue while another person is preparing a quick production fix, creating a hotfix branch. Okay, how much do I have? All right. Hotfix branches are created from the master branch. For example, say version 1.2 is the current production release running live and causing troubles due to a severe bug, but changes on develop are yet unstable. We may then branch off a hotfix branch and start fixing the problem. Don't forget to bump the version number after branching off. Then fix the bug and commit the fix in one or more separate commits. Finishing a hotfix branch. When finishing the hotfix, when finished, the bug fix needs to be merged back into master, but also needs to be merged back into develop, in order to safeguard that the bug fix is included in the next release as well. This is completely similar to how release branches are finished. First, update master and tag the release. You might as well use, next, include the bug fix in develop too. Okay. The one exception to the rule here is that when a release branch currently exists, the hotfix changes need to be merged into that release branch. Wait, let me go on. I wasn't focused. The one exception to the rule here is that when a release branch currently exists, the hotfix changes need to be merged into that release branch instead of develop. Okay, now it makes sense. Back merging the bug fix into the release branch will eventually result in the bug fix being merged into develop too through the release branch. Okay, when the release branch is finished. If work in develop immediately requires this bug fix and cannot wait for the release branch to be finished, you may safely merge the bug fix into develop now already as well. Okay, so summary. While there is nothing really shocking new to this branching model, the big picture figure that this post began with has turned out to be tremendously useful in our project. It forms an elegant mental model that is easy to comprehend and allows team members to develop a shared understanding of the branching and releasing processes. A high quality, update. And for everyone who requested, here is the Git flow model source key of the main diagram. Whatever. Okay, I think this is it. Let me open this one. Git power tools for daily use. I don't care about this. I don't really use Git so much that I need to know everything. I work in a team, so I need this. I work solo, that is even easier. So this was a long video. That's it.